Photoelectric effect is when light hits a metallic surface and then an electron is being emitted. So as you can see here, this is light. It's incident on a surface. So this surface, it's called photosurface, but it's nothing but a metallic plate. And then as a result, an electron is being emitted. Now, in order to explain what's happening here, you need to understand the two models of light first. So I'm going to talk first about the two models of light. So the models of light. So you can think about light as being a wave. So this is the wave model of light. And you can think about light as being a particle. So the first scientist who considered light as being wave, he's called Maxwell. So Maxwell, he considered light as being a wave. So he said that it's an electromagnetic wave, which is an oscillating electrical field and magnetic field at 90 degrees. And he said that the energy, so what he said is that the energy of the wave is proportional to the amplitude of the wave squared. Okay, and so for the intensity, so the intensity as well is proportional to the amplitude squared, which means that the intensity and the energy are related. And he said that since wave is continuous, so this means that the energy can be built up. So for example, since light is a wave, so it's continuous, which means that this energy if I wait for a certain time, it can build up with time. So this is what they consider in the light being as a wave. And the fourth thing that they said is that the frequency of light is proportional, or it's equal to, so it's nothing but the number of oscillations per second. So this is according to the wave model. The second model of light is those who considered light being a particle. So the first scientist who said so, his name is Einstein. So Einstein was the one who considered this first. So according to Einstein, he said that light is made up of particles, and these particles are called photons. So let me write this. So light is made up of particles called photons. And he said that the energy carried by this photon, so the energy carried by this photon is proportional to the frequency. So every photon is carrying an energy equal to hf, where h is the Planck constant and f is the frequency of light. And by the way, photon, as we have taken in topic 7, photon, it's chargeless, it's massless, but it carries energy. The second thing that he said is that every one photon gives its energy to only one electron. So this means that the energy is not continuous. I can't build up energy. Okay, so the electron will either take the photon or it will take the energy of the photon or it will refuse it, which means that energy is quantized. And the third thing is that the intensity is nothing but the number of photons per second. So the rate at which photons are being emitted. Okay, so in order to discuss the photoelectric effect, in order to understand the photoelectric effect, you have to think about light as a particle, or else you will not be able to understand what's happening here. So let me prove for you that according to the photoelectric effect, light is not a wave. So let's start first by emitting a red light here. So this is a red light. Okay, so it has a low frequency because a high wavelength. It's hitting this metallic surface. And let's say that at this frequency, electron is not being emitted. Okay, so if I wait for some time, if light is a wave, then this means that after some time, electron will be emitted. But if you wait forever, electron won't be emitted, which means that energy can't be built up. The second thing that I'm going to do, I'm going to keep the frequency of this light the same. So I'm going to keep it, let's say, as red. Okay, but what I'm going to do is that I'm going to emit more light, which means that I'm increasing the intensity. So if I increase the intensity, keeping the frequency the same, electrons will not be emitted as well, which means that the intensity doesn't affect the energy in anything. Now, after some time, if I increase this frequency of light, so I'm increasing this frequency, I will reach a certain value of frequency where the electron is being knocked off. So this means that there is a threshold frequency, or there is a cutoff frequency at which the electron will be knocked off, which means that at this frequency, the energy of the electron was sufficient for it to escape from the metallic bond. Okay, which means that the energy is quantized. The third thing is that, let's say at this frequency, okay, so at this frequency where the electron is being knocked off, I increase the intensity. Okay, so after increasing the intensity, the number of electrons emitted will be more, knowing that they will all be emitted with the same energy. So let's say that the electron has a certain value of kinetic energy before increasing the intensity. After increasing the intensity, only the number of electrons will be more, but all of them will have exactly the same kinetic energy, which means that the intensity is the number of photons per second, and that every photon is giving its energy to one electron. Okay, so by looking at this, you can see that this is best described by the particle model. Moreover, if I keep the intensity as it is, but I increase the frequency more than the threshold frequency, let's say, so what will happen is that the number of electrons being emitted is the same, but they will be more energetic. So they will be moving toward this plate, which is the collecting plate, in a faster speed, which in a more kinetic energy. Okay, so I'll be discussing the qualitative, or actually the quantitative point of view of the photoelectric effect later. So this means that according to this experiment, light is considered as a particle. Okay, so you can tell this because number one, because not all frequencies will emit or will knock off electron from metallic surface, only the frequency, so only photons of frequency equal, or frequency that will give us, so only photons of frequency that give us energy equal to metallic bond. Okay, so the energy by the photon should overcome the metallic bond, or else the electron won't be knocked off. The second thing that we conclude from this experiment is that time has no factor. So the energy is quantized. E is quantized. It's not continuous. And that the photon will give its energy to only one electron. And the third thing that we concluded from this experiment is that if the frequency increased from the threshold frequency, which is the frequency needed to just knock off an electron without having any kinetic energy, then in this case, the emitted or the knocked off electron will leave with more kinetic energy, but the number of electrons is the same. And the fourth thing is that if we shine more light, okay, which means that more intensity or more brightness, then this means that if F is equal to F naught, then this means that the number of emitted equal or more, let's say, okay, so more or equal than the threshold frequency, then the number of emitted electrons is more, but all have same kinetic energy. On the other hand, if the frequency of the photon is less than F naught, then no electron being emitted. So in this case, in a photoelectric effect, this model is the winner. But it doesn't mean that light is particle, no. Because light is considered as a wave in order to describe the interference, for example, or the diffraction, or the polarization. But if I want to describe photoelectric effect or the emission and absorption spectrum, then energy should be quantized, which means that I have to think about light as being particle. So that's it.